There we go. All right, let's see what you got. What you got?
Yep.
You guys should date.
Which is funny.
Oh.
I said multiple times.
Well, you got
The 3, the 13,
It's open.
the 17 and the 21.
Open.
Open.
That's.
Why don't you open it first before you open it? Because he's apparently
That's what
stupid.
you should have.
It's common sense, okay.
Exactly.
Finally got like I'm doing a quick card just like he's still doing it. Cut off.
What happened on Friday? But that's just disgusting.
Nah, shut up.
That was wrong. You have to clean that up.
I just walked to the woods. I live in the woods.
I would have did.
I did. That's disgusting. Yes, I
I
did.
had hot Cheetos too.
That's not gonna happen again.
Oh, you did number 2 for number 1.
You have music.
Yeah, I got to stay hallway. I'm not in 20 last time. I didn't know what.
I just kind of start making.
No. No.
Is you should get glasses.
Oh,
Oh,
You get a brush?
what?
That's good, although I don't like it right
Sean, your favorite
now.
type of Jets? Where?
What? Hey, Ron.
How did the pattern would be how you can
His mom's.
Oh, the pattern that allowed. Yeah, that would be right.
That's very.
Oh, you're good.
Hey.
Yeah, you did
Did
too.
you get like pissed?
How about you say?
What was that?
Someone trying to rip the
What?
I want to get one for you. Can I get it?
All right. That's good.
This is what? I'm sweating. That's what it is.
This today's the ticket. You don't have to make it up if you want to. You can do it at lunch. One day. You don't really need it.
I got one to
Ain't gonna lie, Mr. Good was on a BB bill. I didn't know how to do it. And I know I put in there, she can do it.
No, I don't think this one did.
I didn't know what you got.
Yeah, because I was on portal.
But that's
the
right.
Yeah, that's, I haven't put this one in.
I swear it said.
I haven't
This
put
is
this
too
one in.
big.
You hasn't, because
Well,
I
it was
was
a different Friday. Remember we had them.
But it says this Friday.
It's not this Friday.
Oh, maybe, I think I did put some of them in. Yours was one of them. I'm sorry, you're right.
Yeah.
So yours wasn't in yet. I just got through a few of them and I
You
went
got a
in.
what?
88.
Almost a hit.
You got this.
Leo, you come on.
Yeah, you look like a mommy princess.
I thought you said my name.
Yeah.
Like you like a gay makeup.
I'm about to be done, bro.
That's good. But you weren't done when I came by, so that's not good. All right, here we go. Again, I have a lot to cover today. I can't be putting up with these distractions that I'm already hearing. So knock it off. We got a skinny day, and I'm trying to get through pretty much a full lesson in a skinny day, which is going to be a little tricky. But we're going to do it. So in this particular lesson, this is your topic. If you didn't already write it down, you want to start your new topic. It's called Arithmetic Sequences. There we go. Arithmetic sequences. It is another topic where there's not a ton of math and it's not complex math. But there are some definitions. You have to understand some new notation. If you understand that stuff, this I don't think will be a very difficult exit ticket. That's up here on the board.
So. for the grace period over, like, what can we do to get our grades?
Do well in the exit tickets. If you haven't taken an exit ticket, or if you haven't taken the big quiz, you can make up anything. You have to make up the big quiz because it's in as a 0 right now. You don't have to make up exit tickets, but you can. But don't come in and try to make an exit ticket up when you haven't studied, because it can still hurt you as well. So it can help you or hurt you. Right now, if you didn't take it, it doesn't hurt you. It's like it never existed. But if you take it, now it exists, and you need to get a good grade on it. We have only really, I think I said this in the last class, not this class. This is it. This is the last week, really, for your grades for the report. We have exams next week, so there's a totally different schedule, so I'm not even sure when I see you. We might try to squeeze in an exit ticket next week if I see you and we can work it in. But depending on what the exam schedule is, it's not like a set, it's not like a normal week where I'll see you Monday, Tuesday, and then Thursday. They've changed the schedule for exams. So I'm not counting on doing any exit tickets next week. So this is it. You might try to get 2 in this week, like one little one and maybe like what I would call like an activity that I just count as a quiz, basically.
You see, it's not there.
Yeah, but I don't know when I see you on the other days, but we'll worry about that later. All right, so in this particular problem, all we're really doing is the same thing we've been doing for weeks, months, really. We're using a pattern of addition. We said before, rate of change is a pattern of addition. Said that was the very first note you took. Rate of change was a pattern of addition. We said rate of change is the same thing as slope. So again, if rate of change is a pattern of addition, and slope and rate of change are the same thing, then slope is a pattern of addition. This is a pattern of addition. Pattern of addition is what makes something linear, by the way. So we'll get into another lesson way down the road where we talk about a different kind of pattern. So you know what I'm talking about. So pattern of addition is just, that means it's linear. That's why everything we've been doing has been based on a pattern of addition, no matter what the different topic is. It's all under the topic of being linear algebra. If you want to come in at lunch, but again, you need to be ready for it. Don't just come in to make it up, because right now it doesn't count against you for an exit ticket. You make it up and you take it, it can count against you if you don't do well. I mean, it can help you if you do well, but it's not hurting you right now. So if you're not ready for it, don't make it up. Like now the big quiz, which I think you took though, the big quiz would have hurt you, but I don't think you missed the big quiz. So most of you were pretty okay with like the questions in this thing. It's not going to be that much different when we move on to like what makes it more complex. We are working with numbers that are in what's called a sequence of numbers. Sequence just means there's some kind of pattern. In this case, for arithmetic sequences, the pattern is based on addition. We're adding 4 every time. And that allows us to figure out what x would be, because we know we're adding 4 every time, so that tells us what x is. And most of you, I think 1, maybe 2 people made a math mistake on it. Oh no, that's right. I think I saw a couple of 24s out there maybe and didn't do the math right. Should have been 25. And then if I ask you what would the number before 13 be, well, there's a couple ways to figure it out. I could say, okay, what number plus 4 equals 13? That's one way to do it, and you get 9. You could also reverse the pattern. If I'm going this way, I could reverse the pattern and do the opposite. And instead of adding 4, if I'm going that way, I'm subtracting 4. So you could say 13 subtract 4 is 9. Either way, you should get 9. That's really the basic concept behind everything we're going to do today. But we are going to, of course, as always, make it a little more complex. Any questions or anything on that page? Pretty much everybody, I think, had the right answers if you finished it. So real world stuff. This is absolutely used in the real world. It is typically used in like architecture, design, even if you're just doing something around your house, like if you want to put tile into your bathroom and you want it to have like what's called a checkered pattern, like that's a checkered pattern, the pattern of how many tiles you would need is based on this type of sequence. If you were building the pyramids thousands and thousands of years ago, which you wouldn't want to be one of the people building the pyramids because they were all slaves and that would not be fun. The pyramid, how many blocks they needed would be based on the same type of sequence. Every layer is adding more blocks, because obviously I need more blocks for this layer than I did for that, and then more for this than that. But the number of blocks they needed was based on the pattern. And you could really, if you really got into advanced math, you could figure out based on how tall you wanted it to be, how many blocks you would wind up needing too. So this stuff is used for sure. Whether or not you'll use it, I don't know. I mean, I've used it before when I've had some kind of pattern and I wanted to figure out a certain number. I've used it before. Not as often as I use the slope and y-intercept stuff. But. All right, so we already did this. We figured out the pattern was adding 4. So plus, these are the same numbers, by the way. We figured out x was 25. And then we figured out what the 8th term would be. Oh, no, I'm sorry. We didn't figure out the 8th term. So I want you to figure out the 8th term. So you're figuring out what the 8th term would be now. If you're not sure what I mean by term, this is the first term. Second, third, fourth, fifth. So I've given you the first, well, I gave you all of them and we figured out that one. So we know the first 5. I just want to know what would the 8th term be. So go ahead and figure that out real quick. You will have a question that's probably about that easy on the exit ticket, one of them. Then you will have some that are hard. What are you doing? I'll give you, I mean, you should be done really already. I'll give you like 30 more seconds. Just got a whole thing telling me what to do. And it literally says on the board. It's a whole other story. All right. Raise your hand if you got it. Don't say the answer yet. Raise your hand if you're like, yeah, this is the easiest thing I've ever done in math. Raise your hand if you got the answer.
Literally.
I would really like to see more hands, but what did you get, Damani?
41.
Perfect. All you had to do was say, well, if this is the first, second, third, fourth, fifth, sixth, seventh, 8th term, keep adding 4. 33, 37, 41. How easy is this lesson, right? Piece of cake. Let's see if it's really a piece of cake.
You should have an extra credit for.
I'm about to give a prize for this one right here. Now that you mentioned that. I'll give you extra credit if you want that to be your prize. If you get this right. That's what's up for grabs right now. You really probably should have practiced the other ones, but.
So good.
So I'm going to give you, now this is timed, that's the only catch to it. You can even use a calculator. If you want to get a calculator right now. I'm going to set the timer. I won't start it yet until I show the problem. And you get a calculator, It's going to, I'll tell you, it's going to be based on this same set of numbers. And I'm going to ask you to find, instead of the 8th term, I'm going to ask you to find a different term.
Mr. Gill, I have a question. So the extra that we took Thursday, I'm excused, but the one before that.
Was it an exit ticket?
Yeah.
Exit tickets never count again. Did you take it or you didn't take it?
No, I had to finish.
No, you don't get more time on exit tickets. Like,
Oh.
the exit tickets don't. I mean, they're 10 minutes, 15 tops. And if for some reason I don't give you enough time, I adjust that when I grade them. Like I don't grade every problem. All right, so here, and I won't even start it immediately. I'll let you kind of absorb what it's asking you to do, but it's based on this sequence. You already know the pattern, what you're adding every time. You already practiced on the 8th term. I want you to find the 426th term. I didn't tell you it was going to be easy. Never said it was going to be easy.
Never mind.
Yeah, you don't well, I mean, I'll show the numbers, that's fine.
Okay, got it.
426 terms. You got an answer already? Holy, I didn't even start.
Okay.
If you have an answer, you can bring it up to me. So far, nobody's gotten it right. Okay. If you think that it was easy, it's not that easy. Oh, no, but that's a different answer than I've gotten all day long. Pretty close. Closer, you're the closest one, closest anybody's come so far. But not correct. Money's scared. Right logic, but not the correct answer. You're onto something. Nope.
Girl.
I think it's right.
No, you're going the wrong way, I think. No, right logic. A lot of you have the right logic. Oh, time went off, by the way. So I'll check this one last one.
I'm pretty sure this is wrong.
Yeah, that's too big. I do wonder how you got that. I'm curious, but all right. So let's talk about what's happening here, because a lot of you are really close. Aiden, you were definitely really close.
What about we have?
It's 106.
No. Ooh, closer though. Well, you and Aiden together were really close.
1,702.
What's that?
I got 1,702.
Nope. Yeah, a lot of you were close. So let's talk about what's going on and why some of you didn't get the right answer, even though you had some of the logic right. So what's going on in this? What are we doing? What's happening to the numbers? We already said it. We're adding 4 every time, right? And why did some of you get a number that was like 1,700-ish? Different 1,700. What did you do?
Yup.
So you guys said, well, wait a minute. I'm adding 4 over and over and over again, right? If I'm adding the same number, the shortcut to adding the same number is multiplication. So you had the right logic. And again, I tell you all the time, math is not necessarily about just what the topic is in the lesson. It's about being logical, improving your logical thinking. So you had the right logic. Let me just go through this. So here's what you had to tweak, though, to get this right. Let's think about the numbers we already know. So we already know these numbers.
I just want to say a random number. They kept tying. 69,800.
No, not even close. The 1,700 was much closer.
Okay.
So here's what's happening. We're adding 4 every time, right? Said that earlier. Let's look at the numbers we have, and this is exactly how you go through a logical thinking process. If I wanted to just pick, somebody tell me which term they want to find. First, second, third, fourth. Well, it can't be first. We'll say third, fourth, fifth, sixth, seventh. Which one? 7. So let's say we want to find the 7th term, and we're adding 4 every time, right? We know that. Well, that's horrible form. Did we actually add 4 7 times?
No.
How many we added?
4.
No, not 4. Count how many times we added 4 to get to the 7th term.
8.
Oh.
8.
To get to the 7th term, you added it 4 times.
Oh,
6.
Not 8.
6.
How many times did we add 4?
7.
Not 7.
8.
Count how many times I added 4 up there.
1, 2, 3, 4, 5, 6.
6, right?
You said 6.
You know how many people?
A lot of people said 6.
Yeah,
But some people were not saying 6. I was trying to get them to look at it. Some people were right, but some people were still wrong. So I was correcting the people that were still wrong. Oh, I'm sorry. I nodded my head on the 6. Nobody caught that apparently. So I'm adding 4 to get to here once. There are 2 numbers, but I've only added once. So the number of times you add the 4 is 1 less than the position you're going to, because you can't count this number. This number doesn't count because we haven't added 4 yet. So the first time you add 4, you've actually involved 2 numbers. So the second spot, we've really only added 4 once. So you have to subtract 1, and this is where some of you made the math. Although I think, Camille, you got this part right. 425 5 times 4 is part of the equation that you would need. So I think, Aiden, that's what you missed. But you got the part right that nobody else got right. In that this is how much we're adding. The math on that, by the way, comes out to be that. That's how much we're adding, but that's not the answer. Why isn't that the answer, Aiden? Yeah, we didn't start at 0. We added that number to an original number. Because think about it, if I started with 1,000,000 and then I add 4 every time, is my answer going to be 1,700?
No.
No, I got to take into account where I started. Kind of like when we graphed, we had a starting number that was the y-intercept, and then we figured out what we were adding every time, although we normally did that in like a graph form, but same concept. We have a starting number, and then to that number, we're adding 1,700. So that would have been the correct one.
1,700.
Well, 1,713, because I take this, which is what I'm adding, but I'm adding it to the first number, so I get 713. So that would have been the answer. 420. If you don't get any of that, you're not following the logic, don't worry. It's not going to kill you on the exit ticket. We're going to go over what you need to know on the exit ticket. You did? Oh. All right, so now we're going to take the logic that we just used and create really 2 formulas, but one of the formulas we're not going to do much with because I don't like it. It's dumb. I'll show you that one briefly and you'll copy it down. Yeah, it's really all we really just did is the y-intercept and the rate of change. Rate of change is based on a pattern, adding, and then the y-intercept is our starting number, our initial number. We've talked about that before, so it's pretty similar, but the formula does need to change a little bit. Because again, the y-intercept and slope and all that, that doesn't take into account that we need to subtract 1 from the 426 number that we just used. This formula does take that into account. So you're copying all of this. You really only have to write the formula. I'm sorry, you really just have to write recursive formula. You don't have to write the whole sentence. But then you do need to write everything in here. So you can just write recursive formula and then all of this stuff. And we're going to define well, it's already defined, but I'm going to explain what all that means. Oh, I was going to find some paper too. I'll give you a couple of minutes. Remember, I'm recording this, so for some reason you don't get it all down, I move on, because I do need to move on to get through the full lesson today. You can go back and you can't get notes from somebody, you can go back and watch the part you missed in the video. Raise your hand if you've ever gone back and or watched a video with your rep.
A what?
That's enough. You were absent. Yeah, you were absent a lot. What's that? Oh yeah. Yeah, that's the thing about having brothers and sisters. Somebody gets something, probably both. And that's for anything, cold, flu, anything. Do you really? Yeah. Are the others younger or older? How much older? Oh, like, probably 18 or something. Yeah, I wouldn't have thought. Unless they were in geometry last year. They're 19. When you're done, just kind of put your pencil down so that I can tell people are finishing up. You have got to have the notes for this topic. This topic is all about the notes. If you don't have I'm not going to write formulas up. I expect you to have that stuff. I'm not going to create a sheet for it with the formula on it. This lesson is not that difficult. And you need to rely on having this. You have this down? Then Maybe. Depends on when I get started. If I've already started, then no. Which would have been a good reason to finish copying that pretty fast. Yeah, exactly.
Boy, it's the same thing. I've got my previous to those things.
That.
Oh my god.
Well, common ain't gonna do you any good when I ask you for the common difference, and you're like, well, I just have common. I don't have common difference. What is that? All right.
Can I leave now?
Go. All right, so we're gonna define some of these things. I feel like some of them are a lot easier than others. So I'll start with the easy, what I consider the easy stuff. We had a pattern before, and I'll just kind of use that example. You've already got it. If you want to write it over again, if it's not on the same in the same place where you're taking your notes now, there was our sequence. Oh, a sequence, by the way, doesn't end. Like, I may stop writing at 25, but if I tell you it's a sequence, that implies that it keeps going on forever. Like, it doesn't stop. That's why we found the 426th term, because the sequence would keep going. The easiest thing I hope to explain is what A1 means. It says it's the first term of the sequence. So what do you think A1 is?
The first term.
Which is, so what's A1?
13.
Yeah, it's the first number. That's all that first term just means. What's the first number? So you write whatever you need to write to explain what that means. If you understand just from that, it's 13, then you're good. If this is confusing you by all the first, just write, it's just the first number or whatever you need to write. But it's just you find the sequence and you pull out the 13. That's the first number when you go to replace A1. Like if we were going to put, well, this one doesn't have it. All the A is saying is we want some number from the sequence of numbers. That's all the A means. We want some number. The little subscript thing is telling us which number. Do we want the first one, the second one, the third one, the fourth one? Maybe we don't know which one we want, which means we'd still have a variable there. That's what A to the N means. We'll come back to that though. So A1, those subscripts are kind of like these. They don't mean any math is happening. They're just telling us which position in the sequence of numbers we're pulling from. So if we're pulling from the first position, oh, my board's been messing up. We'll see if it works. Not too bad. So the first number, the number in the first position is A1, which in this case is 13. All right, so again, I'm going to go to the easiest one. I think D is the easiest one. What do you think D stands for? Or what does common difference mean? I mean, it stands for common difference. What does that mean?
The difference between common numbers.
It's just the difference between the two numbers together, you could say. Or it's the pattern, either one. Common difference is if I take 17, subtract 13, that's the common difference because that's what I'm adding every time. I'm adding 4. So either way, you could say it's the difference between two numbers. The key, though, if you're going to say the difference, you need to understand that you need to take this number, subtract the number to the left. You don't subtract going right. So it'd be 17 subtract 13, or 25 subtract 21 to get what the value of D is. Or if you want to say, what number am I adding every time? That's also the same thing. So you write whatever you need to write to explain to yourself how you find that number. Or really more what that number means. We're going to go over how you find it next class, which will be tomorrow. Okay. Oh, and this can be negative. Don't think just because I say it's a pattern of addition that it's always positive. You can add a negative number. If these numbers would have been going down, like if it was started at 25 and then went 21, 17, 13, we would be adding a negative number because the numbers would be going down, getting smaller. So it can be a negative number.
What did I say right here?
N, that is the letter N, just like that's the letter N there. And I'm going to explain that one next. Is that everybody is done with that, right? Because I'm going to zoom out. Right. So that I can show the next part. I mean, you probably can still see it. But. All right. So here's the last one, and without a doubt, this is the one that's the most confusing every single time I do this lesson. A to the n. A sub n, A to the, it's not really A to the n, it's A sub n. To the n would implies I'm doing an exponent or something. So A sub n. It says nth term of the sequence, which I get is kind of a weird thing to even say, much less try to understand. But A still means the same thing. A just means we want one of the numbers from the sequence. We just don't know which one we want yet. That's why there's a variable in there. Because if we don't know a number, remember, then we use a variable. In this case, we're going to use the variable in to say, well, I don't know what that is. But once I tell you which number, for example, if I said I want the first term, well, then we replace the n with a 1, saying we want the first term. If I labeled them, I'm going to zoom back in real quick. Zoom way in, actually. If I labeled them, I would do this. Oh, my board's messing up. Yeah, I can't really. Oh, that actually worked. That's weird. It kind of corrected itself. So if I labeled them, this would be the first term. A2 would be the second term. A3 would be the third term. A4 would be the fourth term. A4 would be the fourth term. So the number part is just telling me which term, which spot we're in the sequence. And the A is saying we want that number itself. We want to know what that number is. So if I ask you this, what's the answer to this? What's the answer to that? I'm going to call on, nope, I'm going to call on somebody. I'm going to call on Jaden. What's the answer to that, Jaden? Brooklyn, what's the answer to that? So why don't we not get on that phone? Somebody just said the answer. All you had to do is. So A3 is saying I want the number from the sequence that is in the third position. That's all A3 means. Sometimes I'm going to ask you a question and you're already going to have a number there. You just got to pull it out. Not just yet. Let me do the next part and I'll let you go. You got the big formula that we need is the next one. So A3 just means what number, so we want the actual number there, is in the third position. And then if we really wanted to do like, well, no, we're not going to do that yet. We'll do it on the next page. So write this down and then I'll let you go. So now copy that down. So this is now the explicit formula. These definitions you already kind of have. They say this one a little differently. You might want to write n as the term number, but you already have the D and you already have the A1. So all you really have to define is that n right now. As soon as you get that copy down, Ryan, you can trade your phone out. All right. When you're done writing it, with pencil down, please. I'm gonna get out of here. 49.
I think it's
49. Last class was 57. This class is 49. I got a couple more still writing. So all the definitions on this are the same. A to the n just means we want some number from the sequence. Although we're not going to use those. We want some number from, we want to pull a number from the sequence. The n would tell us which position we want, but if we don't know the position yet, we would just have a variable there until I tell you which position to pull the number from. A1 would still be the first term because it's got a 1 there. That means it's the number in the first position. D would still be the common difference. What's going on, by the way, between the D and what's in parentheses? This D and this stuff. What's going on there? Yeah, multiplication. That's just like the distributive property, only the number is at the end of the parentheses instead of the beginning. So if you remember the distributive property, same concept. All right, so here, oh, and then the N, which we'll kind of get to, N is the same as this N. It's just telling us which term number we're looking for. Are we looking for the first one, the third one, the 426th one, which is what we did in the other problem, the 8th one, which we did earlier also. So if I ask you, here's how you use that formula. If I ask you and I write that, that's all I'll write. I won't be asking you in words what you need to find. That's why you have to have the notes and understand the notation. What did I just say right there? What does this mean if you were to say it in words? What am I asking you for though? Well, not how. I'm not asking you how to say that. What am I asking you to find? What am I asking you? Yeah, what number would be in if we, and we'd be using the same numbers, we'll say. So the 13, the 17, 21, 25. If we were using that sequence of numbers, or any sequence, doesn't really matter which sequence, I'm still asking you, what number would be in the 426th position, which would be way out, and then you would use the formula to figure that number out, which is exactly what we did before when we solved it out, but I'm just going to use the actual formula, and we'll get the same answer, the 17, 13, even though we did it a little differently than we did it before. So what do I put in place of the A1? What's the first number? All this is going to be is plugging numbers into a formula for the A to get the allowance. So what do you plug in for that first part, that A1? The sequence is the numbers in red below. Down there.
13.
Yeah, it's the first number. A1 means I'm going to pull a number out of the sequence. Well, which number am I going to pull? I'm going to pull the first one. That's what the 1 is telling me. So I pull out the first one. Now, once you write that in there, make this note. You don't have A or 1 or anything anymore. This is the number that represents A1. A1 is gone. We've already taken care of it. It's gone. We don't use it again. 13 is what A1 equals. Like if you wrote it down, you'd say, well, A1 is 13. So if I'm going to use 13, I don't need A1. It's not an unknown anymore. Are you good? You got a question? Oh, I thought maybe you didn't understand something. All right. Now I write plus because that's part of the formula. That never changes. What do I write now as the first thing in parentheses, the end value? What do you think? No. What do you think? Think 4? No. This is, for some reason, N is always confusing. I heard 425 and 426. Oh, just 25, all right. Somebody said the right answer, I just haven't acknowledged. What did I use for N in the other part of the formula? This is N right here, right? Because A sub N was in the formula. I replaced N with 426 because I wanted to know what the 426th term is. Well, if N, so here's your next note, because I don't know why this is confusing, but every year it is. N is always, or this value, this, if it's in here, it's in there. If it's 426 here, it's 426 there. It's the same variable. If you're replacing a variable with a number here, it's got to be the same number. You can never have a different number for a variable. Just like when we did equations. If x is 3 in one spot, it's 3 in every spot in an equation. If n is 426, it's 426 there. These will always be the same. They'll be the same there. They'll be the same there. They'll be the same every time you do the equation. And then I would always do subtract 1. This subtract 1 takes care of the fact that we're only adding the difference 425 times, not 426. That's why we're subtracting 1. And then the last piece is we need to multiply by the common difference, which is the pattern. That's the difference between two numbers next to each other, so times 4. So you'd find that we did the same exact thing here. That comes out to be 700. That's plus the 13 that we did before. So you'd get the same exact, which of course you should, get the same exact answer using that formula. So we'll do more with that, and we'll get into some actual practice. Keep the worksheet. If you grab the worksheet, some of you did, some of you didn't. Please bring that so I don't run out. Otherwise, I may make you copy all the problems down and do them instead of just working on the worksheet.
Can we get movie?
No. No teacher should be letting you leave early. If they do, they're not supposed to. We got not only talked to, well, we got in math talked to by our department head about not doing it. And Mr. Patterson, our principal, said, do not let your kids leave early. So if the teacher's doing it, they're not supposed to be doing it. So don't ever ask me to do it. That's why this is up here. You can read it if you want. There's a lot of other stuff Mr. Patterson said too.
So what was
The teachers are doing that they shouldn't be doing. The exit tickets are graded, if I didn't say that already. I just haven't put them in focus, so I'll probably do that. I don't know what our basketball practice and game schedule is today, but if we don't have practice right after school, I'll put them in right after school. If we do, then I may not get them in until tonight or maybe even Wednesday. If I don't do it today after school, I'm not going to do it until planning period.
Did our varsity team win against Dunedin?
Both teams won against Dunedin. Varsity won in overtime. It was a little closer than it probably should have been. JV beat them easily. They beat them by, I want to say 20 maybe or something like that.
Mr. Gill, they said that they need a new basketball.
Oh yeah?
What's wrong with Justin?
I have a feeling I might
Hey,
go
what
later
was
and get as much detail.
My dog.
Wait, who's do you guys?
Oh yeah? My dog does. I gotta admit, that's
She
one
keeps
great thing
eating
about
at
my
the wrong
dog.
time. She keeps eating
I
He gets hungry
Who's
later.
you got expected
Yeah.
for?
Huh.
and then she like wants.
Have a seat. We don't stand up. You guys know that?
Yeah.
Oh, I understand. Damani! Oh, Damani. Next time I see that, if you do it tomorrow, you're all gonna sit down until you butt touches your seat before you leave. Hate that. Hate it, hate it, hate it, hate it. Hate it. Oh, I gotta stop my recording.